We want to solve the equation 8 sine squared a plus 2 cos a equals 7 for values of a between 0 and 180. This looks a bit like a quadratic, but not quite, because we have sine squared and we have cos. But we have a relationship. We know that cos squared plus sine squared is always equal to 1. And that means I can write sine squared as 1 minus cos squared. So I've got 8, 1 minus cos squared a plus 2 cos a is equal to 7. So I've got 8 take away 8 cos squared a plus 2 cos a is equal to 7. And that gives us 8 cos squared a minus 2 cos a, so we're taking everything over to the right, take away 1 is equal to 0. Now, will we be able to factorise that? I think there's a good chance we will. So let's go for 4 cos a and 2 cos a. It's got to be 1 and 1 to get 1. And if we want minus 2, if we put the minus there, that gives us minus 4 cos a and the plus there. And that does it, which gives us that cos a is negative a quarter, or cos a is equal to a half. Now, let's look at the cos a being equal to a half. There's only one angle in this range, and that's the principal value. Now, we got the calculator, but we shouldn't need it because this is a standard angle. We should be able to say straight away there that a is 60 degrees from that one. Now, with the cos a being equal to negative a quarter, the principal value is going to be, now just let's make sure that we're in degree mode, is going to be the inverse cosine of negative 1 quarter. And that's 104.5 degrees, we'll say, which is in the range. And with both of these, there's not going to be any other value in that range. With the 60 degrees, we'd be there and there for the cosine. And with the 104.5, we'd be there, there, and there. So only those two are actually in the range 0 to 180. So we can say 60 degrees and 104.5 degrees. Okay, so we've now got a different equation. Cosec 3b plus 1 is 2.5. So cosec 3b plus 1 is 5 over 2, which means sine 3b plus 1 is equal to 2/5. Now we want to solve b between 0 and pi, so that means that 3b would be between 0 and 3 pi, and so 3b plus 1 would be between 1 and 3 pi plus 1, and 1 radian is just a bit less than 60 degrees, just to give you an idea, just a bit less than pi by 3 radians. So for the principal value, 3b plus 1 is going to be the inverse sine of 2/5. But this time the calculator needs to be in radian mode. So switch to radian mode. And then we have the inverse sine of 2/5. And that's 0.412. Actually, I might just go a little bit further. 4115. Okay. So, ASTC, that's the principal value at 0.4115. The secondary value would be here, and symmetry means that's also 0.4115, the associated acute angle. We're going in this range, so we need to start at 1 radian, which is about here. And we're going to go to 3 pi plus 1, which will be to this line, but on the second time round. So we're going to go, and we're first of all going to meet this solution here. So remember, we're solving for 3b plus 1 to start with, and that's at pi, take away 0.4115. And then we keep going, and we go through this one, and we come up, and we get to here, which is at 2 pi plus 0.4115. And we need to keep going, and we get to here, and that one is at 3 pi, take away 0.4115, and then we stop when we get to here. This is 3 pi plus 1. So we've just got those 3 solutions. So 3b plus 1 is going to be, so we have pi, take away 0.4115, so that's 2.730, 2.730, 0.1, and this one's going to be 2 pi more than that, so I'm just going to add 2 times pi. So that last one is going to be 9 point whatever that was, 9.0133, and then the middle one is 2 times pi, add 0.4115, 6.6947. Okay, so 3b is just going to be take 1 away from each of those, 1.7301, 5.6947, and 8.0133. And then we need to divide them all by 3. So 1.7301 divided by 3. We'll call that 0.577. And then we've got 5.6947, divide that by 3, 1.898, and 8.0133, and we'll divide that by 3, 2.671, giving all of those to 3 decimal places.